So, good morning and welcome to today's webinar. Today's webinar will be focusing on how to use system bits and integer in iNELS automation system to effectively use in smart buildings. Today's webinar will be running about 30 minutes. I will cover all the topics related to bits and integer, how we can use it, how we can use it in a project, and how we can use bits and integer for third-party integration. These are the main three topics which I will be discussing today. So stay tuned for 30 minutes. And if you are unable to join all 30 minutes, you will be having this webinar recording in your email after this webinar. And is there any questions or anything comes in your mind during this webinar? Please use the chat feature to ask your question, and at the end of this webinar, I will be answering all your questions. Okay, so let's get started. How to use bits and integer effectively in building automation system. So for those who do not know about iNELS, I am just giving an introduction. So iNELS is a comprehensive building automation system from ELCO-EP. We are there in the market since 30 years, and we have over 50,000 installations all over the world. I'm talking about only smart homes. This system is designed for home, office, hotels, and other commercial spaces, so you can use it for any purpose. And we offer wired and wireless options in iNELS. So that means if it is an existing building or if it is a new building, you can use our system in different scenario setups. Even if you want to extend, still we have options for you. And our system offers scalability and customizable. So whatever the client requires, we can offer it for you. And it can be scalable using our wireless option. And the other key important advantage of iNELS system is that the support of integration with third-party system. So as you know that there are number of open source home automation platforms available. So our system is trending and up to date. It can be used in IoT projects, open source platforms. So iNELS is capable of integrating all the components of it to the third-party system. So this is also the important topic which we are discussing in this webinar with bits and integer. So you will be interested in this topic. And user-friendly interface. We have iNELS application, iNELS cloud, and also using these bits and integers, you can use our iNELS system with any third-party application. So yes, you heard it right. We can be integrated to third-party systems seamlessly, and there are a number of options. You can control iNELS with different options. So today's webinar is about understanding the basic setups of system bits and integer. So after this presentation of slide, I will show you the screens. I will share my screen showing how you can program or add the system bits and integer into your project, so that you will be it will be easy for you to understand and pick up the logic. So what is system bit? System bit is a binary operation element which stores a binary value, either 0 or 1, or an on or off status. Yeah. So it is just a virtual unit. It is not a physical unit. So this virtual unit can be linked to any real unit in the bus system. So that is the basic basic description of a system bit. So we have this system bit in as a virtual unit in the iNELS IDM programming software, and this virtual unit can be used in the programming to create different kind of scenes, automation, logics, and so on, which we will discuss in the later session. And system integer. So integer is also a numerical operating element which stores the integer value. For example, dimmer. Yeah, so dimmer will copy a value, analog value. That means it will go from 0 to 100. So if you want to set a dimmer, then you can send to the dimmer that, okay, set dimmer to 50%. So you can use system integer to copy this value and send it to the dimmer. So you can use analog copy and so on. We will also discuss it later stage. Then what is the example? What are the examples of system bits? So you can use system bits to turn on or off any lights or scenes, and system integers to set a brightness to 50% or to set a temperature to 21 degrees Celsius and so on. System bits, what are they? Okay, so I will explain more about what is system bits. So what is system bits? So system bits comes in the system manager, and here you can see a system bit. So when you press add button, you can add system bit. So you can use maximum 560 system bit in this project. So I am adding, for example, 3 system bits, and I am naming these bits to bit on, off, master on, evening lights, and a condition day. So you can use system bits for different applications. So select these option for exporting the system bits for the third-party integration, and in the alias you can use on and off, just in case if you need these. If you are confused, then you can use this alias to recognize these system bits in the iNELS cloud application. Okay, so then the next step is that you can drag and drop these system bits in the design plane. So here is a system bit, and you can select all of the system bits here. I have 2 analog lights. So I can copy, or I can create a function with these bits to turn on the lights. So on and off, and then you will get 2 actions in the system bit, whether if it is on and if it is in off stage. So if it is on, then analog on, and then if it is off, then analog off. So now we create a function from system bits to turn on some lights. Yeah, it is a very basic principle. But how we should turn on these bits? So there are different ways we can turn on these bits. Yeah. So option 1 is we can turn on or trigger these bits within the iNELS unit. So I am using PMS3, our motion detector. So in the controls, I am using a detector, motion detector, and I link to this motion detector. So I will create a logic that if the motion is detected, I will trigger this bit. So if there is a movement, then I will turn on this bit. So when the motion is detected, digital on this bit. If the motion is not detected, then turn off this bit. Yeah. So now this bit is triggered when there is a movement. Yeah. So this is the first way we can trigger the bits within the iNELS system. The second way how to trigger the bit is through third party. So we will discuss it in the last section of this this webinar. So condition 1, we can turn on, turn off these bits. Second two, the condition 2 is that you can create a scene that here in the system bit we created an evening lights scene, or for example a movie scene or evening light scene. So if I want to trigger this evening scene, then what I will do, I will go to the function and then I create a wire to all those lights which are evening. So I create this group of light in the evening. So when it is on, analog on, and when it is off, analog off. So same way, I wire to the other group of lights which I want to add it in this scene. So again, the channel B is also a evening light. So I add this also there. Okay, so I create a scene with the bits that these two group of lights are in the evening scene. So that means with the bit, I can create a scene. So if I want to create a evening scene or morning scene or movie scene, or if I want to trigger some action, like when there is a movement, if I want to trigger a group of light, then again I can use a bit as a mediator and then create a wire to all the group. So this is advanced automation logic which you can use in the project for different scenarios. The third application which commonly used in the system bits are for condition. Yeah. So again, if I will set a system bit for a condition night, and then I go to this evening scene, evening lights, and add a condition, digital input on, analog on, only if the system bit, this condition is satisfied. So this case also we can use this bits. So you can use bits as simply on and off. You can use bits for creating a scene, and also you can use bits for creating a condition. Yeah. So now I'm just using one simple condition, but you can use many conditions for different kind of applications in your project. So this is how we can use system bits effectively in the project. So next, I will show what is integer and then how we can use integers for different applications. Integers are just a numerical storage unit where you can copy different analog values to iNELS system using these integer element. So I discussed it before. You can copy some temperature values. You can copy some dimmer values and use that values to trigger some scene in the iNELS automation system. So that is why mainly we are using system integer. I will show you some good example with the system integer. So same way you can use system integer to turn on HVAC system. So when the integer value is some above some value, then you can turn on the heating system. Also, if there is, for example, if the system integer value is something, then you can copy that value to dimmer to turn on these lights and so on. And also you can use integer as a condition. So let's go to the screen, and then I will show you what we can use these system integers for. So here in the manager, system manager, in the system integers, you can also create different integers. So I create this integer for integer dim, and here is for color change, and here for temperature. So you can export this value and then store it. So after this, you can go to design plane, and you can drag and drop these integers. So it is already there here, and you can select all these integers we created in the system manager, and then you can copy this value to the dimmable light. So go to function, and then you can see here I have already did something. Okay, I will remove this and I will do the wire again. So integer dim, I use this system unit A, and then if the system integer changes, then analog copy this value to the dimmer. So that means whenever there is the change in the integer value, it will copy that value to this dimmer unit. So that means the dimmer will get that analog, what value are there in the dimmer, then it will copy that value there. So how we can use integers to copy, or how we can trigger this integer. So for example, I don't know if I have some, okay, I will add a unit, WSB 20, and then in the controls I add that switch, and then I create a wire for the integer. So when I press up, short press, or I will use long press, system integer increment. And if I long press down button, system integer decrement. So this is how we can set the integer to increase the value and decrease the value. And also you can start, when the system starts, you can copy some start value, integer value with some particular value. For example, when the CU starts, you can copy the integer to some set value like 0 or 50 or something, and then it will copy that value to the dimmer. So this is the one way you can trigger, you can set analog value to the integer. The second way is you can use, okay, this is one way, and also you can use some light intensity sensors, for these integers. So let me see if we have some light intensity sensor. Yeah, we have a light intensity sensor. So here also we can copy this value to the system integer. When sensor value change, system integer copy value. So this is the other way you can. So you can copy the value from analog value from inner system itself using increase and decrease analog values using the wall controllers, glass controllers, and so on. Also, you can copy some sensor values to the integer and then trigger these values. Also, you can set the integer from the third-party system, which we will discuss later. Then you can use integer for the conditions. Yeah, so I will show you one example how we can use conditions in the integer. So the best example or which we use this integer as a condition when we use human-centric lighting control. Yeah, this is a very recent development which we made using CU309. There is a block, function block in the function block manager for lighting control with analog level 5, for example, or analog level 3. So in this, you can copy some integer value. So I copy this integer value and I need to turn on this with some integer. And then I should control the brightness of this output. Yeah. So here I will show you what are the conditions which we made in this lighting control. So if you go to this analog value, here you can see the set level. So when there is a light intensity, then you can turn on the or set the output with different conditions. So set value. If the light intensity is lesser than 250 lux, then set the dimmer to some value like 100%. So then if the light intensity sensor is lesser than 250 or greater than or in between 250 and 850, then set the output dimmer to 50%. Yeah. And if the sensor value is higher than 850, then turn off the light. So these are the different conditions which we can use with integer value. So this is the best example where you can use integer as a conditional element. So the inner system will use these analog values and use this as a condition. So when the light intensity is lesser or greater, so these conditions and restrictions which we can use in the inner system with integers. So that are the main advantage of system bits and integers in the iNELS automation system. So next we will talk about third-party integration with bits and integer. So this is really a game changer in the iNELS automation system because we use system bits and integer for third-party integration through MQTT. So there are many applications which we can use these system bits and integer in different projects. For example, if you have building with 50 CUs and you want to control all or one light from each CU and make a control group control of all CUs through any third-party system. So in that case, you can use system bits from each CU, for example, 50 CU, and use some third-party integration to send a command in MQTT to turn on all these CUs together. So this is one example. where you can map commands to system bits to turn on some events in the CU or in iNELS system. So that is one example, and exchanging real-time status via system integer. So for example, if you want to send temperature value of one CU to a third-party system, so you can copy this integer and get this value in MQTT and store it to any third-party system. It will give real-time data. Whenever there is a change in temperature, it will copy this value to third-party system over MQTT. Triggering automation and rules. So you can use this bits and integer in different automation or open source platform or third-party integration, third-party BMS system to trigger any automation and rules in the iNELS system. So we use bits and integer to trigger these events. Publishing system states to third-party platforms. For example, we have recently had an integration with Netix BMS, so where we use any status change in iNELS system. For example, if the door is open or if the window is open in a hotel, then it will send this window door detector in the iNELS CU will map to the system bit, and the system bit is triggering or publishing this value in the MQTT, and this MQTT is copied in the Netix BMS so that real time when there is any change in the door position, window is open, then it will trigger alarm in the third-party platform, or it will publish the system state to third-party platform. So overall, this is a bi-directional integration. So you can get any values from the third-party system, and also you can publish this to any third-party system using bits and integers. So I recommend to use these virtual platforms like bits and integer in your integration for any purpose or any integration in the third-party system. Yeah, as you know, in the Home Assistant we have many devices added. Like if you have SA3, you will get SA3 itself in the Home Assistant. But I would rather prefer to use system bits and integer, which will make more flexibility and more. It will give you more logics. It will add more logics to your automation. Yeah. So now I will share my screen to show you the different platforms where we use system bits and integers. One second, let me. Okay. So here is an example of how we use system units for integration. So as I mentioned before, we use MQTT for this third-party communication. That means all the IoT platforms, open source platform, BMS platform are now using the MQTT. So we are also using the MQTT for this third-party integration. And as I mentioned before, you can publish the data and you can also get the data. So here is a topic structure. In the beginning, in the top, you can see iNELS status. So that means it is publishing the events in the bits and integer to the third-party system. So those systems who have subscribed to this topic will get the real-time data which is published from the iNELS. And they can also send some commands to iNELS using this topic. iNELS set MAC address of the CU, bits, and the topic ID or the device ID of the integer or bit, so that they can send some messages to the iNELS system. So this is an example of the set, the status. So it will give you the time, real time, and then the state, and the 000 means the bit number 0, and the status 1 means that bit is on. So you can get the status of 40 bits in one topic, and also you can set these topic, set some command to bits, that is command, bit number, and either toggle or on or off, so it will change the state in iNELS system using the set topic. The main advantage of this bits and integer in the CU is that it is using JSON format. So that means you can parse this data using different open source platform. See, in this status, you are getting one topic, one payload with 40 bit status, so you can parse this data and get only one data from the bits. So I can also show it in the next session how we parse the data. Okay, so here I have created a logic in the iNELS, Inspinia Sky platform to trigger some events in the iNELS CU to set and get commands, 2 bits and integer. So I want to control, for example, some lights or some scenes from the Inspinia screen. So I use this UI object switch. So you can see this as a switch, and it will give the condition on and off status. So sorry, before that I will show you what I made in the Inspinia. So I added an MQTT plugin. So this is my MQTT server, username and password, and then I add a topic. So here I add a topic integers, and the topic iNELS status MAC ID, this integer value, and the number, also the publishing topic. So these two I added, and then I drag and drop it in the design plane, so you can see it here. Then so I want to set something from the Inspinia. So I use the UA object to send this value to this MQTT topic. So I use this UI object switch, and then from the output I give a data parser JavaScript, and here I have created a script to turn on the bit number 1 to the value. So the value means the value which is given from the switch. So when I press the switch, it will give value number 1. So it will store, it will condition that value and make it into this MQTT payload format. So I discussed with you before, this is the payload structure we want to send the data to the iNELS system. So it will parse that, or it will format that that one value to this payload structure, and the output it will send to the MQTT plugin, and this plugin will publish that value to the iNELS system, so that it will change the value in the iNELS. And this status condition, the status topic, will give the real-time data. So when something is happened, then you need to see the status in the Inspinia or in the screen. So it will get that status, and then it will parse that data. So first it will create or filter the state, and then it will filter the object bit number 1, and then that state will be copied, and then it will go back to the switch. So this is the easy way which we can trigger some commands from the Inspinia to the iNELS. if anybody want this program, I can give you this program, so you can just copy this and add it to your Inspinia project, and then you can use this logic in your automation. So the advantage of this MQTT plugin or this MQTT logic is that if you have one or more CUs in an installation, like CU39, CU310, CU38, then you can use or you can create some scenes here, and you can give commands to all the screens together using this MQTT topic. Then I will show you the MQTT payload. So here you can see the MQTT Explorer. I have the MQTT Explorer here. Here you can see the CUs are connected or no. So there are two CUs which are connected, and this is the status. And here you can see the bits and integers. So here you can see the bit status and see the topic structure, how it is sending the data. So bit 0, we have created 5 numbers of bits, so you can see the real status of each bits here. And then you can pass the data, and you can update these data to any third-party system. And also the integer values, 100, and these are the integer values which are there in the system. And if you want to set some values to the integer, then you can send it here. For example, command the integer number and then 41. So here I will copy this value, and I'm going to publish this value here to this topic. So I will send 91 to integer number 1, and then I go publish. It will publish the value. So we will see if that is changed or no. Yeah, so the color change, integer number 1 is 91 now. So same way, I can set the value to 99. So here you can see it is changed to 99. So it is super fast. It is super fast and easy to change these values from any third-party system. So this is how it is like a very simple. If you are changing the command number, now it is integer 1. If you change the object number to 00 and then send 50, the first one will change the value. See, now this is 50. And if I change the second to 50, all will change. And also I can go and do multiple group of integers together by adding that integer numbers here. So it is very flexible, easy, and this is the best and easy way to integrate any iNELS system, any third-party system to iNELS, very easy and faster way. Okay, so I have finished all these topics which I have here for you today.